Alright, so the basis or the idea again behind all of the things that we've been doing in the past hour or so is that we're trying to make big numbers like this smaller so it's easier to use and to work with. It's the same thing with logs. Okay, you're trying to make a number such as this, okay, and represent it into something like this. Okay, so this here is a base number. This would be its log number. This here is its base number, or this is a basic numerical value, and this is the log version of that value. Okay, you can kind of use this as a guide when it comes to coming up with logs for a number. Okay, shh. All right, so considering these numbers, okay, annoying big decimals, they can actually all be written as this. So 0.01 can be written as 10 to the power of negative 2. 0.1 can be written as 10 to the power of negative 1. 1 can be written as 10 to the power of 0. Okay? 1,000 can be written as 10 to the power of 3. 10,000 can be written as 10 to the power of 4. Does anyone see any patterns here with the number and their log? Anyone see anything? Sorry. Anyone see anything? Well, one thing you can actually look at is the number of zeros in that number corresponds to the log number here. So in this case, 10,000 is 10 with 4 zeros. Okay, and you can, it's 1 with 4 zeros. So you can see there's a 1 here with 4 zeros, similar with that log, 10 to the power of 4. Here you've got 100,000, so that means it's 1 with 5 zeros. 10 to the power of 6, or 1 million, is going to be 1 with 6 zeros after it. Okay? And it's the same with your negatives. Okay, so if it's a negative a log number, okay, it's going to be 1 with 2 zeros in front of it. 1 with 1 zero in front of it. Okay? So those numbers up here are called logs. Okay, let's actually use some as an example. Also, in year 11, we're just going to use them a base number of 10, which means that it's always going to be 10 to the power of something, whatever it might be. Let's keep going. So let's look at some examples. Here we've got the number 100. Okay, you want to write it as a log. Okay, you want to write it as a log to make sure that you want to shorten it because it's too big of a number to use. Okay, so in this case, we're going to use 10 as our base. Okay, and if you look at the number 100, how many zeros are there after that 1? There's 2, so it's just going to be 10 to the power of 2. When you put that in your calculator, 10 to the power of 2, okay, the answer is 100. Okay, so we've done it correctly. Let's say you have 1,000. Okay, let's try that for example. If I want to write that as a log, it's going to be 10, and then how many zeros are after that 1? 3. Okay, so it's 10 to the power of 3. Put that in your calculator again. Okay, it should be correct, which equals 1,000. Let's try a decimal. Okay, so let's go to the next example here. What if it was this? Okay, so same thing, right? The base is going to be 10, and then you just need to write down how many zeros are before that 1. So in this case, there's 1, 2, 3. So it's going to be to the power of, instead of positive 3 though, it'll be negative 3. And when you put that in your calculator, 10 to the power of negative 3. Oops. Okay, we get negative 0.001. Okay, same thing if it was like 0.000001. Okay, it's going to be 10 to the power of, how many zeros are in front of that 1? 1, 2, 3, 4, 5, 6. Power of negative 6. Okay. Next question here, finding the log of a number. Okay, so when you get a question like this where it says find the log of 45, all you're literally doing is on your calculator, you just got to find the log number. So in my calculator, I think it's different for everybody, but you need to find your log number. I can't remember where, oh, here it is. Okay, this is my log number here. Literally just press log, and it says you're finding the log of 45. Correct to one decimal place, so log of 45, close the bracket, equals 1.65. I want one decimal, so it's going to be 1. So my calculator go log 45 is equal to 1.7. Okay, 1 decimal place for that one. Okay, so that's that. You could do a bunch of other numbers. Say like log of, let's try 30, I don't know, 92. Okay, so log of 92. Okay, on your calc, press log 92. Close the bracket. 1.96. You can round it to 2. So equals 2. Also, this is doable if you have a CAS calculator. So when you have this, I'll just show you a quick tutorial on this. When you have a CAS calculator like this, you can actually do the same thing, okay? But you got to get familiar with some of the buttons here. This here is the log button, but you got to press Control log, okay? And it does the same thing. When you get this though, just put 10. Actually, no, that's more complicated. Let's just do this. Press L-O-G. Oops. So you'll notice there's a keypad here. You can actually use different functions here just by typing it. But log, for example, of 45, close bracket. If you get that, just press Control Enter, and then you get 1.7, which is the same as what we had on this one when we did log. Okay, when we did log of 45. Okay, same exact thing. Oops, sorry. Okay, 1.65321. All right, let's do the last bit there. Evaluating a number whose log is this. So what this is saying is, when you're asked to find a number whose log is this, all you have to do is 10 to the power of that number. Okay, so it's going to be 10 to the power of 3.1876. So just put that in your calculator. Remember, we're just going to use 10 as our base, so 10 to the power of 3.1876 and 1540.28. It says 1 decimal place, so 1540.28, so it becomes 3. Alright, and that's basically it. So pretty straightforward, I think. Do those questions, and then we'll take a quick break. Okay, so that should take you